Greetings to dear students. In the last video, in the last three videos, we have seen the formula if A is a simple pole to find the residue of the function f of z at that point. Okay, so this lemma is for the pole of order greater than 1. Okay, so if A is a pole of order greater than 1, then the residue of f of z at the point A is equal to g power m minus 1 of A by m minus 1 factorial if f of z is equal to g of z by z minus a the whole power n, where g of z is analytic at A and g of A should be not equal to 0. Okay. So let us prove this formula together. So what is given? A is a pole of order greater than 1. And f of z is equal to g of z by z minus a the whole power m, where g of z is analytic at a and g of a not equal to 0. Okay. So this is a higher derivatives formula. So higher derivatives formula means, okay, we know Cauchy's integral formula. What is Cauchy's integral formula? Okay. So what is Cauchy's integral formula? F of z naught is equal to 1 by 2 pi I integral over c f of z divided by z minus z naught into dz. Here the order is 1, that is a linear equation. So suppose if it is has some 2 means, how we find the integral value of this? So again we have formula for this. If it is has order greater than 1, we have formula, that is fn of z naught is equal to, okay, is equal to n factorial divided by 2 pi I into integral over c f of z divided by z minus z naught the whole power n plus 1 into dz. Okay, so if the denominator part has order greater than 1, means you have to apply this formula. So this formula is known as higher derivatives formula. Fn of z naught is equal to n factorial divided by 2 pi I into integral over c f of z divided by z minus z naught the whole power n plus 1 into dz. Okay, suppose if you have order 2 means 2 can be written as 1 plus 1, so that this is equal to, here in the place of n we have 1, so you have to differentiate 1 time. So f dash of z naught into 2 pi I, here n is equal to 1, so into 2 pi I divided by 1 factorial. Suppose if you have 3 here means it can be done as 2 plus 1. So therefore the value of n is 2. So you have to differentiate 2 times and substitute the value z naught. Then find the value of if double dash of z naught. Then multiply by 2 pi I by 2 factorial. When n equal to 2, this will become 2 factorial. When n equal to 3, this will become 3 factorial. So using this formula, we can find the value of what? F of fn of z naught. Okay, so okay, here the function f of z is of the form g of z by z minus a the whole power m. So what will happen by, okay, it is of the form some g of z by z minus a the whole power m. So therefore by higher derivatives formula we have g power n of a is equal to the formula n factorial divided by 2 pi I integral over c g of z by z minus a the whole power n plus 1. But here we have m. Okay, here we have m. So if n plus 1 means we are differentiating n times. If it is m means we should differentiate m minus 1 times. Okay, 1 will reduce. So therefore, g power m minus 1 of a is equal to m minus 1 factorial divided by 2 pi I into integral over c g of z by z minus a the whole power m. Okay. So now, now g power m minus 1 of a by m minus 1 factorial. This will come this side is equal to 1 by 2 pi I into integral over g of z by z minus a the whole power m. But g of z by z minus a the whole power m is equal to f of z into integral over c f of z dz. By the definition of residue, 1 by 2 pi I integral over c f of z dz is equal to residue of the function f of z at the point a. So therefore, residue of f of z at the point a is equal to g power m minus 1 of a by m minus 1 factorial if f of z is equal to g of z by z minus a the whole power m. Okay, so these are the four formulas we are going to apply to find the residue of the function at a particular point. Okay, so once again, I will recall the four lemmas and the two definitions. Definition is a residue of the function f of z at the point A. The point A should be an isolated singularity. Okay, is nothing but the coefficient of 1 by z minus a in the Lorentz series expansion. Another formula is residue of f of, sorry, another definition is residue of f of z at the point A is equal to 1 by 2 pi I integral over c f of z dz. Okay, if A is a simple pole means we have three formulas. First formula, residue of f of z at the point A is equal to limit z tends to a z minus a into f of z. Second formula is if f of z is equal to g of z by z minus a, then the residue of f of z at the point A is equal to g of a. If f of z is equal to some h of z by k of z, provided h of a not equal to 0 and k of a equal to 0 and h of z and k of z are analytic at a, then the residue of f of z at the point a is equal to h of a by k dash of a. If a is a simple pole of order greater than 1, then and f of z is equal to some g of z divided by z minus a the whole power m, where g of z is analytic at the point a, then the residue of f of z at the point a is equal to g power m minus 1 of a by m minus 1 factorial. G power m minus 1 of a is means what? You have to differentiate m minus 1 times, and after then you have to substitute the point a, then find and then you have to find the value of g power m minus 1 of a. Okay, so with these four formulas and by the definition of residue, we are going to solve, we are going to find the residue of a function at a point. Okay, we will see the problems in the next video. Okay, so thank you dear students, thank you.